So one of the things we can do with these complements is actually do calculations with them. So let's ask a question, right? What is the probability of drawing a card that is not a face card? Okay. Well, there's a couple ways we can do this. We can do this the straightforward brute way, or we can use the fact that the probabilities add up to 1. So if we were going to do it the straight up calculation way, right, we would need to count up the number of non-face cards. I will certainly let you do that, and divide by 52. And this will certainly get you the answer. Or we can use the fact that if we draw a card, I either draw a face card or I draw something that is not a face card. Those are the only two options. And I can use this fact to calculate the probability of not a face card if I already know the probability of the face card, which I already do. All right, so here's the thing we're going to use. The probability that I draw any card is equal to the probability that I draw a face card plus the probability that I draw something that is not a face card. Okay? I either do this or I do that. So the probability that I draw any card has to be equal to 1. The probability that I draw a face card is something I've already calculated, 2308. So this is the only thing I don't know, but this is a nice straightforward calculation. Okay? So the calculation is going to go like this. Right? The probability that I have something that is not a face card is the probability that I draw any card, which is 1, minus the probability that I draw something that is a face card. And so what's left over is the probability that I draw something that is not a face card, 0.7692. This is a little more than 3/4. So we just saw an example of something that is our complements. Okay? We call two events in the sample space complements if there are no parts of the sample space that are in both sets. Okay? There is not a card that is both a face card and not a face card. And we also need that these two things add up to the entire sample space. Okay? So I either draw a face card or I draw something that is not a face card. Those two things add up to the entire sample space. I either draw a red card or I don't draw a red card. Those things add up to the entire sample space. So we need there to be no overlap. There can't be any pieces that are in common into both bits. And they need to add up to the entire space. The notation we like to use for this is if A is our event, then not A, the complementary piece, is A with a little superscript of C. Sometimes you will see it as A with a bar over it, but yeah, if you see that in a different class, they will mention it there. And so in general, our entire sample space, either an event happens or that event does not happen, right? Or the complement. Okay? Either I draw a 2 or I do not draw a 2. Right? Either I draw a jack or I do not draw a jack. Right? So if we have information for either one of these things, we can use it to calculate the other. So figuring out what the probability of drawing a jack is pretty straightforward because there are 4 of these things. And the probability of not drawing a jack is then 1 minus the probability that I do draw a jack. So the entire probability space minus the 4 times that I can draw a jack, 4 over 52, comes up with a probability of 0.9231 that I actually do not draw a jack. Okay? However, sometimes we want to find the probabilities of things that are a little more complicated. So we call these things OR events. Right? So what's the probability of drawing a red card or a face card? Okay. In our case, if we look through the deck, there are 12 face cards and there are 26 red cards. But we've counted our 6 red face cards in both sets, right? Our 6 red face cards are in here and they're in here. So we've counted them twice. So here's what we do. The probability that either event A or event B happens is the probability that event A happens plus the probability that event B happens. And then anything that isn't in both A and B has been counted twice. So we need to remove one of the countings. Okay, so let's use these calculations to figure out what's the probability of drawing a face card or a red card is. Okay, the probability that we draw a face card we already know, that's 0.2308. The probability that we draw a red card we already know, that's 0.5. And the probability that we draw something that is both a red card and a face card is our 6 out of 52. Okay? So if we put all those calculations together, right, we get 0.2308 plus 0.05, and that we've counted this 0.1154 twice in both sets. Okay, so we have to subtract off one of those, so we only have one left. So the probability that we'll draw a face card or a red card is 0.6154. It's a little more than 50%, which is about what we would expect because we're already taking, half the cards are red, and then we're really just adding in the 6 black face cards. So we would expect that to go up by a little bit. Okay, so that is a quick introduction to probability.